Chapter 5, page 9. Optical activity, polarimeters, and physical properties of enantiomers. One interesting property of optically active molecules is that they can twist or rotate light. If you take two compounds that are identical except one is the R and one is the S version, or the enantiomers, and you pass plain polarized light by them, which is light that has a certain specific frequency and all of the wavelengths are going in one direction. If you pass them by one of the enantiomers, it might rotate light in one direction, and if you pass that same light by the other enantiomer, it might rotate light in the opposite direction. This can be measured in a polarimeter. If we take a consistent light source, a sodium lamp, and pass it through a filter that knocks out all of the wavelengths but one, and then pass it through a polarizing filter that knocks out all of the directions of light except for one direction, like we showed above. Then you pass it through a sample container. The standard sample length is about a 10 centimeter or 1 decimeter container. If the compound in there is optically active, it will rotate light. The analyzing filter is nothing more than a little filter here that can measure the number of degrees it's been rotated either clockwise or counterclockwise, viewed from the detector. Imagine your eye here at the end. If you see the light being rotated counterclockwise, we would call this levorotatory, or in the negative direction. And if you see light being rotated in the clockwise direction, we say dextrorotatory, or the positive. Now, two important things to keep in mind. One, whether a compound is R or S does not determine whether it will be dextrorotatory or levorotatory. Some compounds that are R will rotate light in the clockwise direction, and some R compounds will rotate light in the counterclockwise direction. So each compound has to be determined experimentally. The second thing I wanted to get at is sometimes we also abbreviate dextrorotatory with a small d, or we can use the positive sign for how it rotates light, or levorotatory with a small l, or the negative. The last thing to look at here are the physical properties of enantiomers. Enantiomers, the same compound, but one is the right-handed version and one is the left-handed version, have all of the same physical properties with two exceptions. They'll all have the same melting points, boiling points, except one compound will rotate light in one direction and one compound will rotate light in the opposite direction. That's one of their differences. The second difference is that they will each react with other chiral molecules differently, like active sites and enzymes. One isomer might fit into an active site and another one will not. So the only two things separating out the enantiomers, or what you can tell, is the way that they rotate light or the way they react with other chiral molecules.